Load balancer is a service which uniformly distributes network traffic and workloads across multiple servers or a cluster of servers. Load balancer in AWS increases the availability and fault tolerance of an application. AWS Elastic Load Balancer is the single point of contact to all the clients. They can be sent to the nearest geographic instance or the instance with the lowest latency. AWS Load Balancer will distribute your workloads across multiple compute resources such as a virtual machine or virtual server. The application's availability and failover will decrease due to this. You can also let your load balancer take care of your encryption and decryption and let your compute services do their main work. In this amazing hands-on session on AWS Load Balancer, you will learn how to create and maintain load balancer on AWS Cloud. Let's quickly move on to the much awaited hands-on session. And with that, let us take a look at the agenda for this video. First, we'll be looking into the concept of what is load balancer. Then we'll look at the different types of load balancers. Then we'll move on to the components of load balancer. After that, we'll navigate to AWS Management Console and we'll implement application load balancer having integration with EC2 and custom web server. But before we begin, make sure you subscribe to our YouTube channel and hit the bell icon for regular updates from us.
Hey folks, welcome to this session. So in this particular session, we'll be looking on that what exactly is an load balancer and how can we actually use it down. So for understanding purpose, let's navigate to a PPT right over here. So if we go through that what exactly is basically a load balancer. So load balancer is a service that is being provided to us from the AWS end. And using the load balancer, we can basically route our traffic to the registered instances which are there in the target group of our load balancer. So it will do a uniform distribution of the particular traffic that is coming on. And load balancer also increases the availability and fault tolerance of the application. And how exactly that can be accomplished? That we generally accomplish as we send the particular traffic either in the round robin manner to our server, or else we can also dictate that at what time, or you can say how much of traffic should be going on to which particular instances based upon their target group. So we can also achieve that thing out. So if you give a read to the particular PPT that we have right over here, that will also say you the same thing, that we use a load balancer for the routing purpose of the traffic only. It has nothing to do with the load in general. So it's basically uses, or you can say we use it so that we can route the traffic to the particular servers. Now if we go down and look in, then you can see Elastic Load Balancer is a load balancing service for the AWS deployment. Elastic Load Balancer scale itself as necessary to handle the particular load. After that, the incoming traffic is distributed across EC2 instances in multiple availability zones. As already being specified that we use the Elastic Load Balancer to send the traffic to our instances, and our instances can be present in different AZ also. And after that, if we see, load balancer is the single point of contact for client, because whenever a request will come from our client, it will be hitting on the DNS of our load balancer, and from there the particular traffic will be navigated to our instance. Now if we see the types of load balancer, so right over here, if we see, there are three types of load balancer in general. Though we have four, we also have gateway load balancer. But right now we'll be talking about the classic load balancer, network load balancer, and the application load balancer. So if we see, classic load balancer is one of the most primitive load balancer system that we were having in the AWS. But now this classic load balancer has been deprecated due to the current market trend and the type of traffic that we are seeing. Classic load balancer is losing its importance. So even AWS has deprecated this particular feature of the load balancer, but still if you want to use this, you can definitely go for it. After that comes network load balancer. Now network load balancer is the most powerful load balancer out of the three load balancer listed out over here, because if we are using network load balancer, then we can handle huge amount of traffic, and wherever we will require high performance or high you can say traffic processing, at that level network load balancer will be used. You can also see that this is used for handling sudden and violent site traffic. So where we have lot of users traffics coming in, for that network load balancer is much more preferable. Now where do we generally use application load balancer? Let us say you are having a user base who is not interacting that much, but yes, it's not even that very less. So definitely you can go for application load balancer. So if you are in requirement of huge traffic processing, then you should be going for network load balancer. Otherwise, application load balancer will be quite good to go in. Now, if we go in over here, before creating the application load balancer, we need to understand that how exactly does the architecture of our load balancer works in. So for that, let's navigate down to this whiteboard and let's try to understand that what exactly does happen. Now, let us see what happens in the back end. We have our virtual machines running in. So let us say this is our virtual machine 1 and this is our virtual machine 2. So we are having two virtual machines, and in both of this virtual machine, let us say our application or our web servers are running. Okay, so let us say here we are running our application 1 and over here we are running our application 2. Now we want that, okay, whenever some traffic should come upon, then they should be routed down uniformly to both of our VMs. Now how can we achieve that? So over here we need to have load balancer present. So we need to have a load balancer. So this load balancer will be responsible for doing the task out. So whenever a user will send a request, okay, let us say there is a user right over here and that particular user want to send the request. Now how will it send? With the help of load balancer DNS. So this load balancer will be giving a DNS, and using that we can reach out to our thing. Let us say user comes in and hit a request to our load balancer. So for the very first time, that particular request will be going on to application 1, and for the second time, if again that particular user hits it, now that particular request will be going on to our application number 2. So from this we also able to understand that load balancer sends the traffic in the format of round robin. So in the manner of round robin, it will send the particular request. Now we can also specify that, okay, let us say 10 user requests are coming, and if we want that, okay, 8 should be navigated to our application 1 and only 2 requests should go to our application 2, that thing also we can do. But for that we need to use the target group, and over there we have to do. Now generally we need to think now that, okay, what is target group and why do we use it? Now if you see, the primary work of our load balancer is to manage the particular traffic. But what will happen that, let us say if a request comes in, but that request goes to an application which is not available, or you can say which is unhealthy. So at that time definitely the request cannot be processed properly. So for that, over here we have another abstraction level. Now what is that? For sure we will be having our 2 VMs. Okay, let us say over here we have our 2 VM1 with application 1 running over here, and then we will be having our application 2 over here, and this one will be our VM2. And over here what we will have a target group. So we will have a target group over here. Target group primary work is to manage the applications and check their health, that whether they are healthy or not. So this application, or you can say our VMs, get attached to our target group. From this target group then gets attached to our load balancer, and whenever any request comes in from the user, okay, this request that comes into our load balancer, then it will go from here. Now the things comes in that how exactly does our target group check the health of our application? They check it by a specific port. Now generally if we were working with our application load balancer, then we need to enable port 80 in the security group for our machines. And if we launch it, then what will happen? Target group will basically send an request or sort of traffic or signal to our application VM, okay, and that particular signal will be hitting down the port 80, and if the port 80 is opened in our security group, then it will get a message back, and after that it will specify that, okay, it is healthy. then only the health check will pass, and it will be specified that okay, it is healthy, and whenever any request will comes in, then it will be routed only to our healthy instances, not to any other instances. So let's try to see that how exactly can we achieve this architecture out. So for here, so let's navigate to our AWS, and from here let me go into EC2 service. So if you are unable to find it down, just go to global search bar and type in EC2 over here, and you will be able to see EC2 right over here. So just select it out. So once you click on that, you will be over here. So let us go into instances running, and let's quickly launch an instances for our need. So we'll click on instances, launch instances, and over here we need to specify a tag. So let me specify this tag as Intellipaat web server 1. So this is going to be our first web server, our first VM that we are having. For the AMI, we will go with Ubuntu, and the other things are pretty much fine with it. Now if we go in the instance type, if you want to go for some other instance type, feel free to go for, but we'll be going on with the free tier only, okay, so that it does not charge us. Over here, if you want to create create a key pair, what you can do, you can simply go over here, click on create key pair, and over here let us create a key pair. So let me give it a name like Intellipaat, and over here I'll then click on create key pair. So this key pair of ours will be getting downloaded. Now once we have this particular key pair available, we can simply now navigate to our network settings. We can click on edit, and over here let us rename our security group. Let's name it as Intellipaat Load Balancer security group, and in the description also I'll provide this same down. And over here you can see only SSH is being allowed. So with SSH we need to also allow another rule, that is HTTP rule. Okay, over here it is HTTP rule, and you can see the port range that it will take up is 80. So we need to have this one open, and in the source we can make it anywhere. So these are the things that we need to do over here. After that we need not to do anything. So you can see we have our security group that is here, Intellipaat Load Balancer security group, and the things have been specified, SSH and HTTP. Now once we are done with that, we will simply go in, and we can launch 2 instances, because we require at least 2 instances to see the things. So let's launch 2 instances right now. So you can see that okay, we have 2 instances available. If I'll click on view all instances, we are having 2. So let me rename the other one out. So here let me rename it as Intellipaat web server 2. So now we are having 2 instances out. So we'll wait so that the instance state become running, and after that we will go inside it, and then okay, now it's available. So let's get into it. So we'll select it out, we will hit on connect option, and over here we will then navigate to EC2 instance connect, and then to the connect option. So over here now we are connected. So let me clear out the content of here. So the very first thing that we will do once we get connected to our machine is that updating it. So we'll use sudo apt get update. So we are updating our machine, and this update have been fetched from apt-get library. So over here you can see it's being available, means the update has been done. Now once the updation has been done, what now we can do is we can now install our web server right over here. So for installing the web server we can go with Apache. So I'll type in sudo apt get install apache 2-y. So we are installing the Apache web server. So now the Apache web server has been installed. Now let's check in that whether that Apache web server is now visible or not. You can copy the public IP of the particular machine, and over here let me paste that thing down, the IP of the web server. Okay, you can see upon the public IP this particular Apache page of ours is visible. Now you can see here only they are saying that, okay, if you want to replace the file, you can go to this location and do the replacement. So let's now go to this location. So over here, we will type in cd/web/www/html and we will navigate. Now if I'll do ls over here to list out the things that is being present, you can see a index.html file is there over here. So actually this index.html file is the particular file due to which we can see this content out. Now what we can do is we can insert some our specific data instead of index.html. So for that what we can do is we can type in sudo echo and we can type in that this is Intellipaat first server. Over here we will do it, and after that we will type in index.html and we'll hit enter. Okay, it says permission denied, no worries, we will do sudo su, and now if we just simply copy paste it, we will paste it over here. Okay, now the content has been done. Now if we go in and if we refresh this page out, you can see it is saying that, okay, this is Intellipaat server, Intellipaat fast server. Now similarly, let's get connected to our second machine as well and let's do the same changes. So we'll get connected to the second machine of ours, we'll hit on connect and we will get connected to it as well. So it's going to be the same process. Again, we have to update our machine. Before that, let's clear out the content. So first update our machine, sudo apt get update. So we'll update our machine first. And once it is being updated, let's install the Apache page. So we will have to type in sudo apt get install apache 2-y and let's install the Apache. Okay, so now it's being installed. Now if we take the public IP of our machine and if we navigate over here, let me open up a new tab over here, and if we paste that particular page, you can see we are having this Apache page. So let's do the changes. Now how to do? Similarly, let's navigate to the location where this is being located, var html. So let me clear out the content, and over here if we will do ls, you can see this index.html page is there. So to do the changes, let's from the root user, and after that what you have to do, we have to type in echo this is Intellipaat second server. So we'll type in this and then we will put it down to index.html page. It runs successfully. Now if we go in and if we refresh this thing out, you can see this is Intellipaat second server. Now we have two web servers running up. Now it's time to do a load balancer attachment. So for that, what we will have to do, in the same EC2 service, you need to go down, and over here in the resources, you will find load balancing, and over here you will find option of load balancer and target groups. We'll go to load balancer over here, and here we will get an option of create load balancer. So we have to go to over here and we have to click on create load balancer, and here we are going to get a number of options like application, network, gateway and classic as well. So we will be going on with application load balancer. So we need to go with this option of, we'll click on create, and over here we will see that we are getting an option of create application load balancer. Over here we need to specify a name. Let me specify the name as Intellipaat load balancer, Intellipaat load balancer, and over here you can see it is being there. Now in the scheme we will make it internet facing, and over here we will go with IP address only, and over here it will ask us, okay, what VPC do we want to go in. Now if you see, this is the default VPC only we are going on. Okay, over here we are going on with this 172.168.0.0/16, and you can check in, okay, what is the last particular number, that is 85AA. If I show you up people over here, let me go to EC2. So we all also have our machine in this same VPC. So we need to keep our particular machines and our particular instances in the same VPC. So if we select it down, let me select at least one. Let me go to networking option, and over here you can see in the VPC it's 85AA only. So this will give you an idea that okay, we are going with this same VPC only. And after that, in the mappings, you can see we can choose all the options of AZ. So depending upon the instances we can choose, or else we can choose all the AZ. There is no harm in it. And over here, now it will ask us that okay, what type of security group do you want to go in? Now we will be going on with the security group that is there with our machine only, Intellipaat Load Balancer SG. And in this we have allowed SSH and the option of HTTP having port 80. Now here comes the option of listeners and routing. So now we have to create a target group, and in the target group we have to register instance. So for that we will click on create target group over here. And over here it will ask us, okay, choose a target type. Now we are going on with instances, so we'll go with that. We are not going with the other options, so we'll choose that. And over here, let me specify the name for it, and we'll give it a name like Intellipaat target group. And over here you can see the protocol is 80. So based upon this particular port range only, it will check the health of our instances, and it will validate whether our instance is healthy or not. So we'll do no changes to here. Again, the VPC will be default only, where we have our instance says load balancer. In the same we'll keep our target group. And you can see the health check protocol is, they are also specifying that okay, it's going to be a HTTP only. And after that we will click on next. And over here you will see we have to register our instances. So we will select both the instances, and after that we will click on include as pending below. And over here you can see the port 80 they are specifying, and the current state of our servers are running. And you can see the security groups and the AZ as well. So we'll now hit on create target group. So now the target group will be getting created, and over here if we go in, so we have this target group, Intellipaat target group, and over here right now you can see the health status is unused. Okay, so now a health check will be performed, and they will be letting us know whether it will be healthy or unhealthy. So if it becomes unhealthy, then the traffic will not be routed to your unhealthy instances. Only if it is healthy, then only the target, or you can say the traffic, will be routed. Now after creating target group, we have to go back again to our load balancer, refresh this down, and over here now if you will click on target group, we can see Intellipaat target group option is being given to us. So we'll choose it down, and after that we will go on, and now we will click on the option of create load balancer. So now you can see successfully created the load balancer. So now if we click on view load balancer over here, we will see the DNS is now being given to us, and currently the state is in provisioning. So we need to wait for a couple of minutes maybe, so that once it's up and running, then we can use the DNS name, and we will be able to see both of our web servers in the round robin manner. So now let's keep on refreshing it down, and we will see the changes happening in real time. Over here you can see it's being initializing. So it will take some time before it gets initialized, and after that we will be able to see that whether they becomes healthy or they becomes unhealthy. Okay, so this is our load balancer, and right now it's still under the provisioning state only. Okay, so let it get up and running, and we will then be able to see the things down. Okay, it can take a couple of minutes, but you can now see the health check has been passed and our instances are becoming healthy. Okay, they had been validated that okay, they are healthy. So you can see both of our instances are healthy. Now if we go to load balancer and if we check in, and our load balancer DNS is also being given, and now it has came from provisioning state to active state. So now if we copy the DNS name of our load balancer, and if we paste it down over here, let us say paste that thing down over here, the DNS of ours, you will see we are able to fetch this two load balancer, or you can say two web servers, using the DNS of load balancer of ours. So now if we refresh it, you will see this is Intellipaat first server. Now if we refresh it down, it will say, okay, this is Intellipaat second server. So in the round robin manner, it will be keeping on to send the traffic. So hope you like this session, folks. See you up in the next session.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job.